Well, thank you everybody for coming, and I'll pass it over to Coach Keith and let him take it away.
Well, hi everybody, and thanks for joining us. Our topic for today will be advanced driver assistance systems. Specifically, we're going to talk about how collision and repair shop roles may kind of pan out as this moves forward. A little bit about me. I am the Vice President of the Collision Division at ATI. Lots of years of experience, more than I want to tell you. But what we do is we do a lot of work out in the industry on a bunch of different topics, but mainly on new things that are coming to the collision industry so that we can get everybody to kind of share that information together so that everybody benefits. So coming to a road near you, these are autonomous vehicles. You're not going to see them still for a little bit, but I live in Virginia, and one of the research facilities that is building specifically that vehicle in the middle, but they're building all of the radar and so on for that, is located right at the University of Virginia. It's about an hour and a half away from my house. So occasionally we get to see these things riding around. Of course, you'll still see some of these things from the Google vans and all. They look pretty similar, but they do totally different things. So this information, these vehicles, they're here to stay. I will tell you, the one in the middle there, that Subaru Outback, I actually bought one of those. And the reason I bought that car is because of all the equipment that it had for ADAS. Takes a little while to get used to, but what we're seeing is there is now a proliferation of this technology in vehicles as we're moving forward. We're going to see significant growth over the next couple of years out through about 2027, when this will be almost a mandatory, it'll be a non-option package on vehicles, kind of like we saw with airbags and then anti-lock brakes early back in the early 2000s. So as we look at these systems, the market by 2025 is going to be about $70 billion. So this is something that if you're not prepared to work on these systems, it's going to be really important for shops that aren't working on it to do some catching up. But those that are, I have even smaller shops, depending on markets, that have already installed all of this equipment in their shops because they know that this is something that's really going to be something that they're going to be having to work with here in the near future. So one of the things that's important for us to understand is that these systems can go down to something as simple as the glass. And this goes back into about 2018. And I know the particular car I have, in the headliner, there's two cameras that read forward of the vehicle. And those things, basically, they do, they're a warning for lane departure in two different ways. You have a side, obviously, that you would see, but it looks forward and it gauges how far you are from the center line at speed. And it will tell you if it's an active system like I have in my car. If I don't have a turn signal on and I hit that center line or I hit the right side line, it's going to shake my steering wheel and our car actually moves it back to the center of the lane. So these are things, when customers get used to those things, they're going to want to make sure that when their car is fixed, all those things still have, all the systems still have the full functionality that they should. So the future is now. Why do I say that? Well, we're looking at systems now. This is a shop that I work with out in Ohio. We can convert or use the four-wheel alignment system in conjunction with, he bought a MaxiSys system from Autel. You can combine those two systems together to give you everything you need to do all of the ADAS calibrations. You have to buy some, I'm going to show you what the parts are that go with it, but it allows us to get more out of the equipment that we have so that we're, especially this is in my circumstance, a body shop situation where now he can not only do the ADAS and everything that he does normally, but he can also do four-wheel alignments in-house now. So what we're seeing is those that are investing in the technology are starting to improve their bottom line fairly substantially. So with this, 10 of the major auto manufacturers have committed to making the automatic emergency braking a standard feature over the next 2 years. So that's pretty important, because for those of us who didn't think this was going to be around as soon as it is coming around, it's not really a surprise to those that have really been looking at the industry hard as to what our expectations are over the next 10 years. But it's important to realize that, you may get a car in a couple of weeks that you've got to do some type of calibration to. So, and this is an interesting one with these poles. This is the azimuth test that's done, and it basically is looking at kind of like the horizon, if you will, towards the sensors in the back of the vehicle, and it's telling you whether things like your parking sensors and so on will work. So this is a very it's an important process, because this is what's going to obviously keep vehicles from touching bumpers in a parking situation. Or if you have automatic parking on your vehicle, it's absolutely vital that these things are put in properly and then calibrated properly. So as we look at these systems, again, there's a lot of synergies that can be developed between mechanical and collision shops. So, if I've got a collision repair shop and somebody else has a mechanical shop, one may decide to do this type of repair, and then the other can do the sublet to that repair facility, and it can be pretty lucrative for both. So 10 manufacturers, again, that we said, and this is over to the right of this slide, shows how this industry is going to be growing. So basically, it tells you what percentage of the vehicles that they produce have these options on them. And you can see we're starting to get in some fairly high percentage of the vehicles that they produce. So this isn't going away. It's going to increase year over year. So it's important for us to understand that through August 2020, another 4 manufacturers, Ford, Honda, Kia, and Nissan, equip more than 75% of their vehicles with these systems. So again, it's the kind of the wave of the future, but it's here now. So they're becoming more frequent repair requirements in the collision repair facilities, especially right now. There's mandatory inspection processes depending on the manufacturer that you're working with. Kia, Hyundai, and the Asian Pacific Rim vehicle manufacturers have all really embraced this. And you're seeing that again, the systems are in the vehicles. The problem that we have with this is that insurers are not recognizing the requirements of the manufacturers for repair. So that continues to be an ongoing discussion that we have about how do we get it paid for. So it's a lot of documentation and so on. And we'll talk more about that as we go. But there's got to be considerations as we look at these vehicles for how do we set them up, what equipment is required, what technology essentially do I need in the store, then how do I make sure that my technicians are prepared for working on it. So proper calibration requires dedicated tools and equipment. This is kind of like the aluminum deal where we have equipment that is specific to these processes. And I jump by one thing that's important where it says three-dimensional structural measuring. Now, not only do we have the control points for the structure of the vehicle, but we also have the control points for the sensor mounting locations for the vehicle as well. So I know in the training I do with estimating, that's a second set of measurements that we want to check. Once we put the vehicle back together, let's find out exactly where these sensors should be by the measuring system, and then make sure that, again, that the measurements are integrated into the balance of the repair process, so that when we do the calibration process, we make sure that the systems all can be reset and function. So it's not just limited to scanning the vehicle, because that's a big misconception with these systems, is that the scan is all you do. Well, no, that's not true. The scan is how we start. That's going to give us a health check on the vehicle, but then we have to go into the calibration processes themselves. So consumers, what the consumer wants and deserves, as we look at this, consumer concerns, the customers are having a real hard time with some high profile accidents they've seen. The one on the left there, where Tesla went right into the back of a fire truck. People tend to totally become dependent on the system. And you saw what I had on the beginning slide. These are assisted systems. These are assisting the driver. It's not an autonomous system. So that would be a system that operates independent of the driver. So this is going to be a semi-autonomous system. So driver's still got to pay attention. The driver's still got to be prepared in case the system can't react quick enough. So they want to make sure that their vehicle is fixed properly, because if in fact it did avoid a collision, or let's say something that was unavoidable happened, they want to make sure that the vehicle's prepared for the next loss that could potentially occur. So as repairers, it's our responsibility, even if the insurers, don't want to pay for it, we've got to make sure that we're sharing with the customer why we have to do it, because the insurers, obviously, they want to keep their costs minimized, but our responsibility, because our contracts with the consumer, is to make sure that the vehicle is put back to pre-loss functionality. So it's got to look right, it's got to act right, it's got to fit right, but most important to me is the safety systems have to be fully functional as well. So the car knows its surroundings. It's really important to understand that the car is reading the whole time it's driving. It's reading all of these different areas. So, I've got blind spot. I've got around the vehicle. I've got parking sensors. I've got the new one, the dark one there in the center is pedestrian. We even have lighting that has FLIR in it, so that it can read infrared for either animals or humans. Anything that is warm-blooded, it can read that and it'll put more light into that area. There's a lot of different systems that we're talking about here. So why are these options so important to the consumers? Because they're going to be dependent on it. Once they, and I gotta be honest with you, I'm kind of guilty of this too. You get really used to the vehicle kind of looking out for you. That's important, because you're putting trust now into an inanimate object to do things for you. What the consumer is going to want us to do as repairers is to make sure that that trust that they're putting in the vehicle really comes from the trust that they're putting into us as repairers. So these options are important to the manufacturers, because it raises the value of their brand. So they're going to want to make sure, and that's why they've done such, and I think, an excellent job in outlining all of the things that have to get done to make sure that the vehicle's put back into that pre-accident functionality, if you will, because it's that important, not only to the consumer, but to the brand, whatever manufacturer that is. So some of the things that we're getting a lot of pushback on, camera calibration. So a light impact to a bumper system or into a lift gate where we have a camera, that there's nothing wrong with it. It's still working. Yeah, but is it in the right orientation so that it can read properly out of the back of the vehicle? That's why we have to do the calibration. So some of the areas that we look at here: forward collision alert, lane departure warning, lane keep assist, so that's keeping us in the center of the lane, adaptive cruise control, collision mitigation, so that would be the automatic braking system, traffic sign recognition. Some of these will also work off the GPS, pedestrian detection, and then of course blind spot monitoring. And this is only part of the systems that we're going to be looking at. So the important points here are technology is moving at a far more rapid pace than training. That's really important to repairers because we've got to get ready for these systems. Listen, if you're not ready for them now, we're probably a little bit behind the curve. So we probably have to speed that up a little bit. Manufacturers are moving to more systems integration. So we're going to be adding more things into these systems, not less. Specialty tools and equipment are going to be essential. You're going to see that with most of the new technology that we're going to be working on. The need for centralized testing kind of may be a foregone conclusion, especially if you're in an urban, a metro market where you have lots of shops and maybe, the rent's high and it's a little hard for everybody to get the equipment. Maybe there's a centralized location that could do this. Insurers need to get on board about having staff trained to work with these systems. I will tell you, this is an ongoing struggle. I have shops in the Ohio market, Indiana market, that they have a really hard time because the insurance staff is not trained for all these sophisticated systems. So when you're having a discussion with them about what needs to be done, they in some cases are kind of clueless. So when we look at the sensors that these systems may have, I just kind of put a couple of pages of them here so you could take a look at them. But the lane departure warning sensors, they could be in a mirror, they can be in a tail light, and they can be in other areas of the vehicle now. So all the way on the left are what some of those sensors look like. Adaptive cruise control is typically going to be right in the front of the car, either in a mirror, in the headliner, or it could be all the way forward in front of the core support. And you got a crash alert sensor. This is if somebody's coming toward you and you're the one that's at the stop sign, it's going to alert you that somebody's traveling towards you really quickly. If you're the vehicle that's going towards that vehicle, it's going to alert you it's trying to stop the vehicle. The pedestrian wave sensor, again, that's another one that looks at the pedestrian itself, and that will work along with things like an active hood airbag or an active hood hinge that allows the back of the hood to go up in case the pedestrian is impacted. It kind of keeps them from going into the windshield and so on, and it makes it a lot safer for them. Then, of course, you have blind spot detection and the lane keep assist. Those are pretty common. All the way at the bottom, though, I want you to look at the lane keep assist. That is integrated into your steering system itself. So I'm driving along and I go to drift out into that lane. It lets that steering column know that it has to move you to the right side because you're going left. So that's an important one to make sure that it's calibrated, etc. Then you have the LiDAR system on the left. That kind of is looking all around the vehicle, and it incorporates all of the sensors. You've got the rear collision warning, which kind of went over that already. The night vision or the FLIR, that's a forward leading or a rear looking infrared. Typically, you're going to see that mainly as a forward looking night vision infrared. Then, of course, in the forward leading infrared is where it has the photo of the animal that's in there, but it reads the heat signature and lets you know that there's something warm-blooded ahead of you. So these are really important because it could avoid animal contact, could avoid human contact, and these are things that are really important to us as drivers. Then, of course, parking assist. This is a pretty common one that you see with the little sensors that you're seeing in the bumper covers and so on. But again, once it's clicked on, allows the driver to kind of hands off park the car with the vehicle doing all the work. And then, of course, around the view monitoring, that basically, again, takes in all the different sensors and allows them to kind of work together. So one of the realities of what we're dealing with these systems is and this is I pull this out of an article written by Gary Liddell. It's saying that essentially we're taking cars to a dealer, assuming that that dealer has all of the technology there to do this work. I will tell you that we're not seeing that. So, and I love the line there. It says, you take the vehicle into that dealer and you're asking them, you're asking the service manager, can you recalibrate my ADAS system in my vehicle? And then you get the deer in the headlight look. Well, a lot of folks are not trained, nor do they have any kind of even base knowledge of how these systems work. So what happens is, the reality that comes from this is they may not be prepared to do this work. So the caution I always give with this is, if you're subletting work to someone, you have to make sure, and I would ask them, let me see the equipment that you're going to use to calibrate the vehicle. And make sure that you have folks that are well versed and experienced in doing this. It does take a lot of training. Once the training is done, though, it's not as complicated a system as you think, and I'm going to show you some more about that. But the reality is, it leads to real concerns when insurers may, in some cases, refute the need for calibration. I'll give you a prime example. I have a shop in Ohio that they wrote an estimate on the vehicle. It was about $1,200 to $1,300 higher than the insurance company wrote. And the insurance company basically called a couple of dealers and said, listen, this is the damage that's on the car. They showed them a picture and said, do we have to do this test? And both dealers who were not certified dealer or certified collision repair facilities both said, nah, we don't have to do that. So in that state, if you get an agreed price, the problem that you have is, once that agreed price is kind of in stone, the insurance department will not investigate it, because they said, look, you got an agreed price, so that's that. What they don't consider is that the estimate was written incorrectly. Sure, you got an agreed price, but that doesn't mean that agreed price will fix the vehicle properly. So this becomes a real concern. So you contact that service writer and you ask them the question, they don't really know. And then they tell the insurance company, yeah, we're okay, we don't have to do that. So it results in improperly confirming the insurer's position that they shouldn't pay for this item. That becomes a real issue for the collision repair shop. So unfortunately, we're seeing this happen more and more. So going back and getting the OEM documentation is going to be important. So in most cases, the ADAS system is not the only, it's not only about the sensors, it's integrated into other things in the vehicle. So if one's off, more can be off. They affect steering, braking, and other factors. That's a huge deal for us when we're going to give the customer back their car. In the collision repair scenario, the collision repair may have more information relative to these the system functionality than the person that they're speaking to. And I have had that happen. I go and I ask somebody about the systems that they are getting ready to work on, and they're going, what? And I'm like, wow, you really need to look at and show them some information. So this is a way we can help educate folks into understanding. We got to get them more knowledgeable about these systems, because if we don't, we're not playing, it's not apples to apples. We've got apples here, we got oranges here, and we're trying to mesh them together, and it's not going to work. So what does it mean to the repair center? So the repair information it's not determined by the repair center, it's determined by the OEM. The OEM tells us what we have to do. So the repairer then pulls the data from the OE source. You got OEM one stop. Each of the manufacturers has their own individual sites. You've got ADAS Think out there. You've got all different places where you can pull this data. Then once it's identified, we identify what the repair requirements are. So we'll update that information. And then we go to put that into our repair plan, formerly known as an estimate. And we take that repair plan, then it becomes a friction point because we're determining and we've identified with data to support it, information that has to get done. However, the insurance company is saying, no, we're not going to pay for that. You're the only one in this market that charges for that. I'm glad when I hear that, because that means I'm the only one doing my homework. Then you have to go through the discussion preparation for negotiations and so on. And hopefully you don't have to, but typically you've got to get the owner of the vehicle involved. You got to remember the owner of the vehicle has the contract with the insurance company. The insurance company really doesn't owe us in the repair side any kind of conversation, as well as we don't have to reciprocate to them, but we do it on behalf of the customer. But if I have an insurer, any third party payer that doesn't want to communicate with me about why, I'm going to put the customer at risk if I don't do this stuff. I need to do it to make sure that we're putting them back in a good place. That should be, in my mind, enough of a conversation to trigger them to pay for it, but not necessarily the case. They can refuse to pay for health scans, and which, if they do, doesn't allow us to do a baseline of on the vehicle before we start to work on it. That's what the OEMs say we need to do. So the repairer then has to seek out all the information, and in our estimating systems, it's very explicit. It says pulling that OEM documentation, whatever the cost for that is, should be added to the repair plan. Then the time spent deciphering what needs to go with that particular vehicle, that should also be added into the repair plan, because then I know definitively that I've got all the information that is required to repair the vehicle properly. So if they don't want to pay for it, the last block on the right there results in a massive repair delay. Okay. Customer service now becomes an issue. And then we have additional administrative time that starts to increase for the shop. So as we look at these documentation requirements, these are a couple of the ways that we look at it, but the one in the center top is OEM One Stop. Free site, anybody can go in there. A couple of good things it gives us. One is the position statements. So how manufacturers, what position they take on certain information about the vehicle. Then on the right side, it will allow you to get into the area where you can pull the repair procedures. Now, with all of these now in OEM One Stop, you have to click in. It'll put you into a hyperlink to the OEM source. Then you have to pay a fee to get to the data. But again, that fee should be added on to the repair plan. So the repair facility seeks out the OEM documentation. We're going to get all of that. Again, the mandatory scanning and electronic processing pieces and all the OEM position statements are there. To the right of that, so the yellow block right to the right of it is, that's what some of the information looks like from, that's a General Motors informational worksheet, but repair inspections required after a collision. Now, all of the manufacturers specify what degree of damage we have to do this at, and almost all of them say in an accident, no matter how minor. That's how much these systems can be affected by even a light collision loss. On the right side next to that is that's from ICAR. ICAR still is the training authority on new things from the OEM, and they have 11 different classes on ADAS. All of them are virtual, so you can go in and get a good bit of training without having to go sit in a classroom with other folks. But once we do this and we go through this process, that's when we sometimes hear, we don't pay for that. And then again, then I have to go for some customer intervention to get it cleared up. So do we go through all the steps and keep working in-house, or Do we sublet this work to a mechanical repair facility? Now, somebody would ask, well, if it's lucrative, why would I sublet it? Well, let me just tell you a little bit about how this works. If the mechanical shop does this work, they're going to get their full rate, whatever it is per hour. Always on the collision side, the insurance company is going to want to drop the rates. Typically, it's in half. Why that is, I don't know. Why collision repair shops allow that to continue to occur, I don't know. But we have a lot of folks that will agree to do it for cheaper. So it just continues to be like a festering wound that we have in pricing for collision repair. But that would be one of the things that might be a benefit by subletting the work. So again, I'm not here to tell you what to do as far as, alliances with other folks, but if it makes good business sense, it might be worth the conversation to see what could come of it. So as we look at the database information, and I put CCC up here specifically because CCC is about, really close to 92% of the estimating database market right now. But if you look over there to the left, it says ADAS precautions. So I blew that up and it says on vehicles that use advanced driver assistance systems, OEM repair information must be consulted to ensure repairs will not negatively impact ADAS functionality. That's kind of our Bible. That has to be followed. The next area where it talks about restraint systems, same thing. We have to do specific things about de-energizing and then re-energizing these systems. In some cases, like with an airbag, it could be catastrophic if that thing deployed while somebody was installing it and we didn't discharge the system. And they specifically state discharge and isolate the system so that I can't get any current back into an airbag. So these are, again, sophisticated systems. It's not something that we just do because we want to do it a particular way. We have to follow all of the repair procedures to make sure that we're doing them properly. Here's another caution. This is a little bit off of the ADAS topic, but when you're performing repairs on other substrates, so that means aluminum, carbon fiber, whether I'm on boron steel, high strength steel, mild steel, I need to make sure that I'm understanding what I need to do to those different materials in order to fix the vehicle so that the vehicle will be safe. So again, this is telling us, we can't fix a car the way we fixed it 20 years ago, or even 10 years ago, or even 5 years ago. The metallurgy is changing, the systems are changing, the sophistication of the electronics are changing. And with all of that being said, we've got to follow the instructions that the original equipment manufacturers set out for us. So the important points here: estimating systems currently have limited information about these systems. Why is that? A lot of liability in these. So they don't want to cross-reference. Now, you may have additional things in the database that you could use, but I still always suggest go back to the OEM documentation. Make sure you have the OEM branded document in front of you. It will require the estimator repair planner to do extensive preparation in creating their estimate. The research processes and all, like I said, can be added to your repair plan, so the cost that's incurred. Dealers may not be prepared for working on the system. So again, that's a really important point. And again, new friction points basically emerge as we're looking at these new systems. So there was not too long ago, there was a conversation at the Auto Body Parts Association convention about these parts and these systems in particular. And Jason Barton, who is referenced here, he used to be the person who was responsible for all the iCar technical writing. And there's a really good, in that first bullet, these are not recommendations, they are service specifications. I think that is a huge learning point, and then consequently, when we're dealing with an insurer, a huge teaching point for them, that they need to understand that what we're referencing here is a service specification, not a repair process. So these are mandatory things that the manufacturer is looking for us to do. So like pre-scanning, that's required because we need to know the baseline. What condition is the vehicle in right now? Then we can go ahead and fix the vehicle. But unless we do that, we're kind of, shooting in the dark. So we need to be prepared for these things. Again, very minimal. And if you look at the third bullet there, the Insurance Institute for Highway Safety found a misalignment of 0.6 of a degree on an emergency braking sensor. Again, it's because of a windshield bracket, et cetera. The car could not avoid a 20-mile-an-hour collision with a stationary car. So that tells us it's pretty important that all these things are aligned properly and repaired exactly the way the manufacturer tells us to repair it. So this is kind of big news for us. So again, as I said earlier, sensor mounting positions are going to be critical measurements for scanning and calibrating the vehicle. So the estimating systems, again, is an important point, validate that identifying the operations is something we can charge for. Industry professionals identify that the new operations being identified, as we get a new option package, we're probably going to have some new sensors that we're going to have to deal with. Insurers are already looking for ways to lower costs. And how are they doing that? They're demanding the use of aftermarket safety system parts for these vehicles. Think about that. I won't say any more about that, but think about it. Insurance Institute for Highway Safety reinforces the fact that setup for these systems is very specific, and the OEM processes and procedures must be followed. So again, this is taking what used to be suggestions about repair, and now they're getting very specific. We've got documentation, we've got data that reinforces what we need to do. So again, as we look at this, small degree, big impact. That's why our driver assisted systems, we've got to do this right, folks. If we don't, we can end up hurting our customers, and that's not what we're in business to do, for sure. We have two kinds of calibrations that you'll see. There's and one of the other things that's important here, windshields are also part of this, because depending on the type of windshield you get, by manufacturers, some are telling you you can only use the OEM windshield. Why is that? The clarity of the glass and the tint on the glass will run into those sensors. And I know on my Subaru, for instance, they basically say you have to use OEM replacement glass. Nissan's the same way. So as you start, and then of course the higher end European cars are the same way. But the whole thing about using a piece of Nags glass, where did it come from? What is the clarity of the glass, and so on. So the two calibrations we typically run into here are going to be either a dynamic calibration or a static calibration. The dynamic calibration is done on the road. I take my diagnostic tool, I plug it into the ALDL sensor, or the plug, 17-pin plug that's right under the steering column. I plug it in, now I drive the car, and it'll tell me how long I have to drive it, what conditions, and so on, so that the vehicle, the ECU, can recalibrate itself, okay? The other one that we have is the static calibration, which is done in a fixtured system. And the shop that I work with in Ohio that's putting it in right now, this is the type of system that he's putting. So we've got to have some specifics about in-store requirements. It's got to do with 32 feet long, 16 feet wide. That's the area that I need to do these static calibrations. It also says that the floor has to be level from end to end and side to side with no more than 1 degree variance. They're pretty specific about what they want done. So the systems, again, have to be set up in accordance with the OE. Different vehicles may require different testing processes. The repairers must access the OEM procedures. I can't stress that enough. The processes for setting up and completing the multi-step operations, in all cases, it's going to be that way, where it's going to be multi-step. So just to show you quickly, I've got the 3 areas that you're going to do. You've got pre-setup, 3 steps. You've got the setup process, which is 6. And then I go back to the 10 steps that will be for the calibration itself. Again, depending on the vehicle, the time that it takes to do all these will change. So you go off of what the vehicle says. So we had a lot of concerns with this as we were developing a program to even talk about it. So one of the things I asked a bunch of shops to give me feedback as to what time it would take to do some of these things. So I created the list that's up there now that just tells us typically what we see as the times that these shops, and it is an average of what they were doing. So it lets us get an understanding of how long it will take to do all the setup. From Hunter Engineering, and this is the one I showed you, there were some pictures of it earlier. This is using an Autel system. It's the front, the dark piece there, with a Hunter 4-wheel alignment machine. Works really good. Lasers function well together, etc. Then this would be the Autel MaxiSys system on the floor. And the way this is laid out is you're going to have targets that the computer is going to read through the sensors, which I'll show you in a minute. But some things that we need to understand. Vehicle's got to be on a level surface, enough distance for the targets to work, or for the ECU to read the targets and to calibrate itself. You have to have the proper coolant level, your engine oil, a full tank of fuel, no passengers or cargo in the vehicle. Pretty different for a lot of the things that we do. Then you have to have the doors closed, correct tire pressure, and I also have to make sure that the entire time I'm running this calibration process, that I have a full 12 volts running through the system inside the vehicle. So a lot of specifications that we have to follow there. It's a shot real quick of what a floor layout would look like. Again, I've got targets in front that are going to be used for adaptive cruise control and braking. I've got targets in the back for the around the vehicle and for rear crash. And then where those stripes are on the side, we would put things up for doing lane departure warning and so on. But it's got to be set up on a specific grid in a specific way so that the targets can be read. So the process steps identified for each piece of equipment might be a little bit different. And I will tell you, there's lots of different equipment right now for doing this work. Ranges in price from $6,500 up to about $48,000. Depends what you want to spend. Identifying the steps necessary for pricing the calibrations is going to be important for you and will immediately become a friction point with the third-party payer, whoever that might be. Making sure that there is a hard copy of the setup as well as a copy of the invoice for billing. Those are going to be important documents in trying to get paid for all of this. And then steps in some cases are going to be a little bit different. Again, the topping off the fluids, air pressure adjustments. There's even some that say you have to put a sandbag at each of the 4 torque box areas of the car so that we can take, each one will be 60 pounds, so that we can make sure. And what this is all about is making sure the vehicle is at the proper ride height. That ride height is what is necessary for making sure that all these sensors work properly. So again, this is just another list of all the different sensors, but the left side of the screen is passive features. These are just alert tools for you. On the right side, these are the ones that will take control of the car. So you've got a lot of different things that are going on here, and it depends on the vehicle you have, whether these are going to be passive or active. So again, separate and distinct operations. We should never lump the costs all together. We should keep those separate for all the different tests that we're doing. Time to set up and monitor and address the individual DTCs is going to be required. The resets are also considered a separate operation. I have to physically go into the tool and do a reset. In some cases, I may have to reprogram. Both of those would be totally separate from the calibration processes. The final scan to ensure that the DTCs are no longer active is also a separate operation, or your post scan. So I'm going to just walk you through some of the items that we would need for this. This is the Autel MaxiSys system. This is what they call their front rail. It's got a centering, there's a crossbar, the 6-foot aluminum crossbar. In the center of that is a laser pointer that needs to point to the center of the vehicle. Once it's in place, you lock the system down to the floor so that it can't move as you're going through the calibration processes. These are going to be the accessories that will have to be bought for this. I got a night vision reader. I've got a blind spot target. I've got an adaptive cruise control target. Then, in addition to that, the targets are built in 3 different types: American, Asian, and European. You cannot intermix these. It will not register for the particular vehicle that you're trying to work on. On the left side is what we call a complete set. Down at the bottom is what the scan tool looks like, and it's a pretty robust scan tool. It does a lot more than just the calibrations or scanning. Then this is a lane departure warning on the right. By vehicle, it's going to tell you what target to use. Then again, this is the same picture I showed you on the left side, but on the right side is the Autel system all set up for you to use. So the important points with this is the vehicle ride height is one of the requirements for the calibration. The ride height is important since the sensors are made to operate when the vehicle is at rest on the suspension system. So if I just take it off a lift, I can't go through this process until I give the vehicle the opportunity to jounce and rebound off the suspension until it gets back down to its proper ride height. You have to check the fluids. Again, if I have 10 gallons of fuel missing out of the fuel tank, that's 70 pounds. So that would make a difference in how the vehicle would orient off of its suspension. Then the calibration rail aligns to the vehicle, lock it to the floor so that the sensors will work properly. This just are some pictures of the blind spot detection and the technician going through that process, and just through several of the different processes. But each calibration process is a standalone operation in the calibration event. So you have an event with a bunch of different components. Each step in the process will require the specific setup, the frame orientation, those kind of things. And if you can't stress this enough with everybody, it's not a one size fits all process. So the important points, we've got to make the vehicle ADAS roadworthy. When we deliver the vehicle back to the consumer, we want to have everything set. We want it road tested with all those things functioning. We're going to give it back to the vehicle with everything turned on and let them go and use it, turn on. Then they can turn off whatever they want, but at least we want to deliver it in that condition, put that on our delivery worksheet. There are no available shortcuts for the calibration process, no matter who tells you what. The collision repairer must either be prepared to complete everything or align with a sublet vendor to do it with them. Verification of the functionality is essential in this process. So here's some more. If you want to go in and find more about this, I would suggest go into the MaxiSys ADAS in the internet, and it will give you all of the information you need to have a pretty good discussion with folks. This is another piece of equipment that is pretty cool, but it's really expensive. This thing will orientate itself to the vehicle, which is kind of cool, but it's about $25,000 more than the MaxiSys system. You can choose whatever piece you want, but this is made by Chief Automotive, the same folks that make frame machines and so on. There's also other companies that do this kind of work. Aztec is one that will do. They have a mobile service that you can use. This one here is from AirPro. Again, the same kind of thing. It gives us the functionality checks and so on that we need. And as you use these, I mean, if you're not buying the equipment, obviously it's more profitable to do it this way because you don't have the expense of the equipment. But what I'm telling folks, if you're doing this and you're doing a lot of it, it shouldn't take you any more than about 18 months to pay off the equipment. Then if you've got a shelf life of 7 or 8 years on top of the 18 months to 2 years that it took you to pay it off, you've got a considerable amount of revenue that can be generated off the equipment. So the takeaways for this, because we're coming right to the end, the advanced vehicle systems, including ADAS, are placed in new vehicles, are migrating from optional to standard equipment. You're going to see that over the next couple of years. We haven't even talked about one of my favorites right now, and that's EVs. We're going to have electric vehicles that have all of the same functionality. So the next several years, we'll see a significant influx of this equipment. The collision and mechanical repair sectors need to be prepared for this, including consideration for contingency plans for smaller shops that just can't afford this equipment. So they're going to have to align with somebody else that can do this, because if they're going to work on newer vehicles, it's going to be essential that they have an outlet for that work. Then the last bullet there, equipment and training will be vital to repairing vehicles correctly. Emphasis on training. We've got to have people that, reading a scan tool is not that difficult, but going from reading a scan tool and what needs to be done to making sure that the system calibrates to the vehicle, that's a whole nother process. So we've got to make sure our folks are prepared for that. So with that being said, I want to thank you for spending an hour with me. If you need any more information, if you want to talk to me, that's my number, 301-575-9191. I can also be reached at kmanich@autotraining.net. Maddie, that's it for me.
Okay, I don't see any questions in the chat. And I didn't see any questions on the Facebook Live video either. Just a comment about the audio, but that was resolved. But yeah, if you have any questions, feel free to jump in right now, unmute yourself and ask, or you can ask away in the chat, and we'll give that a few seconds of courtesy. But thank you so much, Keith. That was a great presentation. I'm always interested in the ADAS stuff, and it's going to become a lot bigger than it is now in our industry.
Oh, yeah.
Yeah, Keith, can you type your email address into the chat so that if somebody watches the recording later, they can just copy it from there if they have a question?
I'll also put I usually get a lot of questions after, so that's okay.
You just did perfect this time that nobody had any questions.
Yeah, hopefully.
I have to say this presentation, I've seen a lot of ADAS, but this was it was very clear and, easy to understand. I thought, from looking at it from that, the aspect of how the shop kind of operates around it with the insurance and stuff, that was really interesting.
Awesome. Thank you.
All right. Well, I don't see any questions. But yeah, if you do, you have Keith's email and you also have mine, and I can pass him along if I need to. But thank you all again for joining us today, and thank you, Keith, for your excellent presentation. And join us next month for another ATI Coaching Corner Lunch and Learn.
Thank
All
you.
right. Thank you all. Take care.
Bye.